Alright, so this video will focus on Chapter 5, Section 5. And the first thing we're going to do is go through and try to figure out where these points are on a Cartesian coordinate grid. So I'm going to give you a moment to kind of graph out on paper and press play and see if you are correct. So here are all the answers. Again, -2, and then down 4. I'm sorry, I go over 2, and I go down 4, and that's A. And then -3, so 1, 2, 3, and up 1 is B. So this is your X term and then your Y term. So we want to compare two rates graphically. And we're going to be filling out some tables today, working in groups. But I want to show you a couple of things. So the first thing I'm going to do is I'm going to be going from feet or miles per hour to speed feet per second. So let me just quickly write this down and think about what we're doing. So if I'm going from speed of miles per hour, I'll say miles per hour to feet per second. I have to do a couple of steps. The first thing you have to do is you're going to take the number, I'll just put X, times 5,280. And what that's doing is it's allowing me to actually figure out how many feet it is, because this is taking my miles times the amount of feet in a mile to figure out the total amount of feet. And then I'm going to take that number, I'm going to divide it by my seconds, but I have to go there from hour. Now, I know that there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So I'm going to do 60 times 60 and get 3,600. And I'll put that right here, divided by 3,600. So my formula that I'm going to use for each of these to determine the amount of feet per second is this formula, where I type in, so in this case, I'll put in like 61, that's the miles per hour, so 61 times 5,280, and then divided by 3,600. And then my answer is 89.46. So let's just say 89.46. And once I have the formula established, it's actually pretty easy to do. And this, of course, is feet per second. So you'll work in groups and figure all this out. Let's just try a few more. So I do the horse. I know that that's going to be my 43 times 5,280 divided by 3,600. And this is 63 feet per second approximately. And I can just keep on going and putting these different things in. So I think that was a coyote I just did. Look at that falcon though, that's crazy. Let's just figure this one out, I'm curious. It's 200. So if I take 200 times 5,280, and then I'm going to divide that by 3,600. Wow, 293. So 293 feet per 1 second. That's crazy. That's really crazy. All right, anyways, so this is a formula that I'm using if I go from miles per hour to feet per second. Well, now let's go the other way around. Let's figure out feet per second to miles per hour. So in this case, I have my feet per second, which is my X, and I want to go miles per hour, right? So I have second on top, so I want to multiply by whatever it takes to get back to hour. So in this case, it was 60 times 60, so this would be X times 3,600, and I have to divide that by the amount of feet in a mile to determine how many miles it would be. So as an example, let's do this black mamba snake. So I'm going to do 23 or 29.3 times 3,600 equals this divided by 5,280. And so a black mamba snake goes about 20 miles an hour. That's pretty crazy, actually. I didn't know that went that fast. It scares me a little bit. Let's look at like a 3-toed sloth. So I'm going to go 0.2 times 3,600 equals divided by 5,280. So this is like 0.13 miles per hour. So it's not moving anytime soon, right? And then finally a cheetah. Let's figure that out, because it's 102 feet per second. So if I do 102.6 times 3600 equals divided by 5280. So about almost 70 miles an hour. Holy cow, is that fast? It's crazy. So that's the conversion rates between the two. And now it says to actually plot these various ordered pairs between different animals. So if I look here, let's just do like, the three-toed sloth, which would go like 0.013 miles per hour. I mean, it would just be a very slow rate going up. Or I could do the cheetah, which is like 70, so I'd just keep going up faster. And it says which graph is steeper, the one that is a lot faster. This one here says that an airplane is traveling at a constant speed of 6 miles per minute. Make a table to show the distance traveled a distance traveled each minute for 8 minutes. All right, so, I mean, if we do this, I will just have, we'll say my x is equal to minute, and y equals miles. So I'm just going to go through here, and I'm going to make a table. I'll say x and y. So for 0, it's 0. For 1, it is 6. For 2, it is 12. For 3, it is 18. 4, it is 24. 5, it is 30. 6, 36. 7, 42. And then 8, of course, being 56. I'm sorry, 48. All right. And if I describe this graph, it is linear. It will be going up at a straight rate. So if I'm going through here, it will look like this here. 1, 2, 3, 4, 5, 6, 7, 8. And this is going up by 6s. 6, 12, 18, 24. And basically it's just going to be going up at a constant rate. So it'll look linear like this here. All right, so now it says find the missing distances. If this is 0 is going up by 12, so then this would be 24, 36, and so on. This is going up by 6, so 12, 18. So there it is. So this graph will be steeper because it's going up more every second. So this is called a slope, and this is a really important concept for what we have coming up with graphing. And this is really the change in y over the change in x, and that's what we'll be focusing on during this class period. So in this case, my slope is my change in y, which is the up and down, so 3 over 2. And that's how we define it. So find the slope of this one. I'm going up 4, and I'm going over 3. So the slope is 4 over 3. This one here is going up 3 and over 6, so this is going to be 3 over 6, or 1/2. So find the slope of this one. I look between the 2 points. I'm going to go up 1, 2, and over 1, 2, 3, 4, 5. So this would be 2, 5. This one here is going up. It looks like as it goes up 1, it goes up over 3, right? The distance between these points, the x term or the y term, is going up by 3, and this is going up by 1. So it'd be 3 over 1. It says here, look to see what the slope is. This is my change in y, so this is going by 10, and this is going by 2. So this would be 5 over 1. This one here is 20 over 4, or 5 over 1. It's the same thing. So look at the steepness of these lines. Notice how the blue one is steeper, right? Well, let's figure out why. If I figure out the difference, and how you figure out difference is you make a quick table. And I'm just going to say 428. And I'll say 856. And I'm going to find the difference between these. So this is going up by 2, that'd be 30, so 22, so 28. And this one here is going up by 4. So the change for this slope is 28 over 4, or I want to reduce that down even more, I could have 7 over 1. The other slope is going to be, I'll say 4, oh boy. So x and y. I'm going to have my 4, 20, and 8, 40. This is going up by 20. This is going up by 4. So this will be a 20 over 4 slope, or 5 over 1. So if I look at these two numbers, 7 over 1 or 5 over 1, the 7 over 1 will be a steeper slope. And that is the